Welcome to my channel, viewer. This is the successive derivative and n times of derivative, nth derivative. Okay, now today this is about the nth derivative of the class. Okay, now question here is, and n derivative means first derivative, second derivative, third derivative, fourth derivative, and order to nth derivative, where n is an integer, not a fraction. Okay, n derivative is means the n times of derivative. Okay. And for the function, we have given him there root x, and number 2 here ax plus b whole to the power minus 4 by 17. And how can we do it to the nth derivative? We know the first derivative, second derivative. Okay, so how it possible here? See the discussion here about that. Okay, now number 1 point here is y is equal to, given that the x to the power half here. Okay, and if we derivative that is first order, and that is dy dx, and divided by y1 here. Okay, now half into x to the power half minus 1. We can write here half minus 1. Okay, and again if we differentiate, and this is equal to, okay, now this is equal to half into x to the power minus half, and again differentiate this as d2y and dx2, and this is equal to half minus half into x to the power minus half minus 1, and that will be 1 by 2 minus half and x to the power minus 3 by 2. See here, on the first derivative there is a 1, and in the second derivative there is a minus 3. Okay, and again differentiate, we denoted by y3 here, and that is the third order derivative. Okay, half, this is also a minus half, and this is minus 3 by 2 here, and now x to the power minus 3 by 2 minus 1. So we got here minus half and minus 3 by 2 and x to the power minus 5 by 2 here. Okay, let's see here. Again, and this is, and y4, and that is equal to half minus 1 by 2 minus 3 by 2, and again see minus 5 by 2. Okay, and this is equal to x to the power minus 7 by 2. Okay, this is the procedure of finding the fourth order derivative. And now how can we write here the nth derivative? Okay, in the formation of there was a 2n minus 1, and this power we can, this is here 4, so 7 is represented by 2n minus 1. So 2 4 is 8 minus 1, 3 here, that is 2n minus 1, 6 minus 1, 2 here, and this is 2n minus 1, that is 2 minus 1, that is 3 minus. Okay, so write like that. So therefore we can write yn, and that is equal to C4, 1 2 3 4. So number of 2 here is n to the power 2 to the power n, and 1 2 3, the number of minus, that is minus 1 whole to the power n minus 1. If 4, then we got the 3 minus. If 3, then we got the double minus. So like that. Okay, so after the nth order, the minus would be the number of 1 order be n, then minus 1 be n minus 1. Okay, and now see the factor here 1 3 5 and dot, and in the case of after the nth order, last term be 5. This is 3 5. Okay, 1 3 5. So that is 2n minus 1 here. See, if we got here 4, fourth order, then last 4 minus 1, that is 8 minus 1. Sorry, that is 4. Okay, this is okay, now 2n minus 3. 2n minus if we put here 8, 8 minus 3 5, okay, ठीक है. So that is 2n minus 3 here, but x to the power would be, that is 2n minus 1 by 2 here. Okay, so this is the technique of finding the nth derivative. Okay, now again we also have simplification from that. Again, it is the figure here. If we put 3 and then we got 2 to the power 3, so 3 here. If we put 3 here, then 2 minus here. Okay, if we put 3 here, then that is 3 to the power 6. 6 minus 3 is 3. That is 3 here. If we put 3, then 2 to the 6 plus 6 minus 1, that is 5. That is 5 by 2 here. Okay, it is clear. And after that, now formation reduce, and this is like that 1 3 5, and also introduce here the factor 1 2 3 4 5 dot dot, that is here 2 minus 3, and next odd number be 2, this is okay, no, right now here this is 2n minus 3, when we introduce here 2n minus 2, and x to the power minus 2n minus 1 by 2 here. So this is here 2 4 6 dot dot dot, that is 2n minus 2. Okay, so see the formation clearly, that is minus 1 whole to the power n minus 1, 1 2 3 dot dot, to ending term is this, so we can write like factorial 2n minus 2, and also take a common to each of the factor on the numerator, and that is here if we write how many terms of 2 are common, this is right here like 1 2 3 1 2 3, and the ending term is n minus 1. So we can write here number of factor be n minus 1 here, so this is would be n minus 1. Okay, and now this can be written as like minus 2n minus 1 by 2 here, and see this is minus 1 whole to the power n minus 1, and this is factorial 2n minus 2, yes, this is 2n minus 2 here. Okay, this is 2n minus 2 here, and that is 2 to the power n minus 1, and this is also a n minus 1, and x to the power minus 2n minus 1 by 2 here. Okay, this is the nth derivative of x to the power half. This is the smallest formulation. Okay, now question number 2, second question. See the very important question. Second question, see the carefully. And now second question, we want to introduce the power, that is m here. Okay, now m here, this is right here m. Now it is differentiate y is equal to, this is 2 number question, and here ax plus b whole to the power m. Okay, so y1 means first order, so m let us assume any number, maybe any number. So ax plus b whole to the power m minus 1, again y2, and that is equal to m minus 1, ax plus b whole to the power m minus 2. Okay, there is a missing here, derivative of that is a, and this is a square here. Okay, now see the clearly, if we differentiate to the after nth step, this is the nth step here, m minus 1, m minus 2. Okay, and this can be written as let us assume it's be an integer, and m is more than n. So this is the reduced pattern I want to introduce in part by answer. Here is 2, order is 2, so you can write here it is 2, so order is in, so it will be in here, okay. And now there is a point, this is 2 here, but this is here 1. So after the nth term, so number we have m minus, so see here 2 and the ending term, that is m minus 1, this factor, there is a number 0.1 is less, okay, 1 less, so here is n, so we can write here n minus 1 here, okay. And see again, if we find 3 by 3, then we got m minus 1, m minus 2. Students, see here carefully, ax plus b whole to the power m minus 3 here and to the power 3. I mean to say this is a 3 and the ending term be the m minus 2. I mean, if the value here 3 and this is 2, so this is 1 less, and that's why if there is an n, so in this position the m minus 1, n minus 1. So this is the answer, okay. This is the answer. If m is an integer, if given there, so we can also can write a simply representation. And if m is more than n, so you can also introduce a number like factorial m minus 1 here. So this is also m, and this is okay. And no relate to that idea. Okay, this is the answer. And now question number 3. Question number 3. See, y is equal to sin x, sin 3x and cos 3x. For this trigonometrical function, you always arrange in an addition pattern. There is a product, but we should always arrange in addition pattern. So we have a system from the sum and product pattern. Okay, now we have left here 2 into sin x and sin twice x here and cos 3x. Okay, and then 1 by 2 and 2 sin a sin b. So you can write here cos of their difference, that is x here, and also their addition, this is 3x here. Okay, now this is cos 3x here, also can be written 1 by 4. We can write here, this is 2 into cos 3x and this is cos x. Okay, and now 2 into cos 3x, cos 3x, and also can be written here 2 cos a cos b. So we can write here 2 cos a cos b. So this is cos of the addition, that is 4x, and their difference will be cos twice x, and their multiple angle 2 cos square x, that will be 1 plus cos 6x. We can write here cos 6x, okay, and this is equal to 1 by 4 and cos minus 6x, and this will cos 4x, and this is cos 2x, and this is minus 1, okay, and this is y. And now see the differentiation of sine cos like that. If we differentiate y1, then 4 minus 6, and there will be minus also, and sine of 6x minus, and this is 4, and sine of 4x also, here is minus also, is minus, and this is 2 sine of twice 0, differentiate of 1 is 0, okay. And this formation can be arranged like this, 6, and this is minus 1 whole to the power 1. So you can write here, and that is cos of pi by 2 plus 6 here, okay. Now 4 and cos of pi by 2 plus 4x here, okay. And also 2 and cos of pi by 2 plus 4x. Oh, there is a 2 here, 2x. Now you can differentiate y2 and that will be 1 by 4 and again 6, and these also are minus and 6 also. We write here as a 6 square, okay, not needed to 6 here. So now this is pi by 2 plus 6 here, okay, and also 4 square, there is a minus, and you can write right now 5 by 2 plus 4x here, okay, and also 2 square, we can get minus also here, okay, sine of, and that will be pi by 2 plus twice x here. And now rewrite this figure, okay, now 1 by 4, and that is 6 square, and also can be written in the form of cos of 2 into pi by 2, okay, now 6, and same as 4 square, and cos of, this is 2 into pi by 2 plus 4x here, okay, now 2 square, and cos of, and that is 2 into pi by 2, this is 2 into pi by 2 plus 2x here, okay. And then this is y2 here, therefore we can write yn, and this is 1 by 4 and minus 6 square, and cos of n pi by 2 plus 6x, and this is 4 to the power, oh no, this is 2, so it will be here n, and this is 4 to the power n, and cos of n pi by 2 plus 4x here, and also 2 to the power n, and cos of n pi by 2 plus 3x here, okay. This is the nth order derivative of the product of sine 3, okay, sine x cos 3x and cos 3x, okay. And now question number 4, see that carefully, okay, this is the important point. And now take the problem number 4 here, this is also an important point, and see carefully and enjoy the solution. Okay, y equal to d to the power ax and sine bx here, okay. If we find y1, that is e to the power x and b into cos bx here, okay. Now this is here sine bx, and now a into e to the power ax here. If we take a common e to the power ax, then we got the result like b into cos bx and a into sine bx here, okay. See carefully, okay, now I am concentrated to the board and students see the solution carefully. And now this has sine, and we can express whole thing as a sine, so that's why we can express as a sine cos sine. So let us assume a is equal to r cos alpha and b equal to r sine alpha. So the tan alpha is equal to b by a, or alpha is equal to tan inverse, we can write b by a, okay, after in b by a, okay, that is equal to e to the power ax here. If we put b, r sine alpha, okay, and now cos bx, r cos alpha and sine bx, so this is r e to the power x, we can write here, and sine of bx plus alpha. In the ending point, there would be put the value of alpha and also r. If we differentiate also, this is y1, if we differentiate this as y2, so we can write here like e to the power x as a common here. So again we can write r square and also sine bx plus 2 alpha, okay, like this, okay. And same derivative, same as derivative, there is a bx plus alpha, this is a bx plus alpha, put the a and b, this is in this position, we take a common, then r, we got r square, so we got this pattern, okay. Now therefore we can proceed this step, we got yn, that is r to the power n, e to the power ax, okay, and sine bx plus n alpha. Okay, therefore yn is equal to r means, okay, now a square plus b square, this is square plus this is square, so you got r square here, so r equal to within the root a square plus b square within the root, this is half, this is n by 2 here. Okay, now e to the power ax and sine bx here, so n into alpha. Alpha means the arctan v by, okay, arctan in the v by, okay, this is your answer. Okay, and it's ready to use by x and sine bx. Very important question, so carefully, and see also the next point, that is 5. We also use a complex number Drewer's rules here. You know the cos theta plus I sin theta to the power n, that is cos n theta plus I sin theta also. So can you apply here? But now we have to find number 6, point number 5. So see, so there is no real factor, so that's why we have a factor by complex number like x minus ai, and this is here x plus ai. Okay, and now partially factorize this, okay, and this is 1 by twice, so we can write like x minus ai and minus x plus ai here. See carefully, if we take the LCM of this and we got this here, but on the numerator there is a twice a, and so balance by 1 by twice, I think we can write like now. Okay, now also can witness this 1 by twice here and x minus ai and to the power minus 1, and also here x plus ai and to the power minus 1 also. And see, now differentiate, this is the formation of y, so we find like that minus 1, this x minus ai to the power minus 2 and minus 1 x plus ai to the power minus 2 here, okay. And again, if we find y2 here, 1 by twice ai, and this is, you can write here minus 1 minus 2 and x minus ai, and this is minus 1 minus 2, we can write x plus ai to the power minus 2, and I think there is a mistake, this is minus 3 here and this is minus 3, okay. And take a common these two factors, so we can write here minus 1 whole square and also factorial 2, and there is a 2i, and now x minus ai to the power minus 3, and now here x plus ai to the power minus 3 here. So similarly you can write this is or the n step, okay, after the n step, so nth bracket we got here in y suffix n, so minus 1 whole to the power n here and factorial n. If we the order 2 here, then you got minus 1 whole to the power 2 here and also factorial 2. Or that's why if the order be n, so minus 1 whole to the power n and factorial n. And also 2ai is a common, no change there. Okay, now here x minus ai, and that will be the n plus 1. See, if they are 2, then power will be 3. If they are 1, their power will be 2 here. Okay, now, and this is the, if you n and then 1 more here. Okay, now here x plus ai to the power minus n plus 1. And now again, this is the formation of a plus ib pattern. So we want to simplify more, okay. So that's why you can take x is equal to r cos alpha, and also a is equal to r sin alpha. And now x square plus a square, we got r square, and also tan alpha is equal to a by x here, okay. So this is the more technique of finding the simplification. Now if we write here like this is minus n plus 1, so if we put here x is this and a is this, we take a common r to the power, so this is n plus minus 1, okay. And now here is cos alpha and minus and sin alpha, okay. This is minus n plus 1, and see, this is r to the power minus n plus 1, and this is cos of minus n plus 1 into alpha, I into sine, and this is minus n plus 1 into alpha. Okay, so r to the power minus, so n plus 1, and cos of n plus 1 alpha minus minus plus I into sine n plus 1 into alpha. This is the minus pattern. So x plus, similarly we can get the simplification form of this, and that will be r to the minus n from is the same, and if we there is a minus, so there is a minus, so there is a minus plus minus. Okay, so middle value is also also minus here. Okay, this is minus. And now this is the difference between them. So therefore x minus ai and to the power n plus 1, and x minus 2ai to the power n plus 1 here, and this is take a common n plus 1. Okay, this is the difference. So these are taken common, this minus this, so these are cancelled out. So this is into 2i into sine of n plus 1 into alpha. This is the part of that, and we substitute here, and this is from 1 and this is from 2. Okay, so you get from 1 and 2. Therefore y suffix n, and this is 1 and 2. What we get here, that is here minus 1 to the power n and factorial in here, and this is 2ai, this is 2ai, and also the part of r to the power minus n plus 1 and 2i, and also sine of alpha, sorry, there is a n plus 1, there is n plus 1 into alpha. Okay, so minus 1 whole to the power n factorial n, this is a here, 2i are cancelled, so r to the power n plus 1, so this is sine n plus 1 into alpha. Okay, where r square means a square plus x square, and tan alpha means a by x here. Okay, this is the solution. Okay, just if we want to put from finding the value of r and put there, and alpha is equal to r tan of a by x, and put there, then you got the answer. Okay, this is the most simplification for me if you want to simplify it. Now our question 6. I think this is the most longest video for this class. See carefully. Okay, see carefully. See the sixth question. So see here, y equal to x to the power n by x minus 1. Find yn. In the top there are question, find nth derivation of the every function. Okay, so minus 1 plus 1 are balanced. Okay, now factorize this like x minus 1, and there will be another factor, x minus 1, x to the power x minus 2 here, and this is x square plus x plus 1. Okay, and now x minus 1 here, and also 1 by x minus 1. Okay, so x to the power n minus 1 plus x to the power n minus 2, and that is x square plus x plus 1. I can repeat the question here. This is also n is a positive integer, and see the nth derivative, so that's why n is a positive integer, not needed to say there. Okay, x minus 1 to the power minus 1 here. Okay, now find yn, and now written as yn, and see this is the nth derivative, but see within the first bracket which I write here, this is the degree less than the order, so this is derivative is 0, the whole thing is 0 here, so this is the nth derivative of the second part of that. Okay, so this is, see if we give a function like x cube and x square, we find the x cube. If we first order derivative the first order, then twice x. For the second order 2, and for the third order is 0. So degree here is 2, but third order is 0. So like that, degree here and the degree less than 1 here. So less 1 there. So differentiate of this here 0. So now find that is assume a z, that is x minus 1 to the this z1. So that is x minus, okay. So z2 minus 1 minus 2, we get minus 1 whole to the minus 3. So that is minus 1 whole square factorial 2. So x minus 1 whole to the minus 3 here. So z suffix n, so we get minus 1 whole to the power n factorial n, x minus 1 whole to the power n plus 1. Okay. So for this, so and that is equal to zn, that is equal to minus 1 whole to the power n factorial n and x minus 1 whole to the power. Okay, this is another more interesting question. And next point here is Leibniz theorem. What is Leibniz theorem? If we derivative in the product pattern u into v, this is the nth derivative. If it is derived after nth order, then this is the nth order and this is here is unchanged. Then nc1, and if this is nth order, then after the nth order, this is the one order lesser than the previous order. Okay, and increase of this function order are increase from, this is here v is unchanged and this is first order, then nc2, then after the order of un minus 1, then order of the next derivative bn minus 2, and v1 is changed to v2 here, and order to u and vn, and we apply the nth order derivative for this function, question number 8, and then after we discuss this question number 7 here. Okay, now f of x here is 10x, and see the question here, find the solution of sine of n pi by 2 by n pi by 2. Okay, now see the question here, f of x equal to 10x, and tan means sine x by cos x, so cross multiplication method, so cos x into f of x equal to sine x. Then we apply the Leibniz rules. This is the nth derivative of the product function. So if we derivative the nth order of f of x, and that is notation as f to the power n f of x, okay, and into cos x. After that, the formula here is nc1, and the order is lesser than the previous order, so f to the power n minus 1 of x, okay, and derivative of cos x is minus sin x, okay, then nc2 and n minus 2 order of f of x, and derivative of minus sin x is this cos x, and order to infinity, and order to final value, okay, sine of derivative of nth order of that is sin n pi by 2 of x, okay, plus x. If we put 0, then cos 0 is 1, so that is f dash 0. In case of sine 0 is 0 here, so nc2, so there is 0, so nc2 f of 0 n minus 2, okay, plus dot of this, and put 0 here, so n pi by 2 here, okay, so n pi by 2 sine of that is equal to this, is your answer. And for the last question, that is the point number 7, question number 7. See carefully. See the question here, y equal to sine m times of sine inverse x. So y equal to sine into m into sine inverse x. So first order derivative here is y1, and derivative of sine is there is cos of m product of sine inverse x, and again they will differentiate this here m by root over 1 minus x square, okay, and squaring both sides. For the first point of the 7th question, sorry, y1 square, okay, and this is cos square m into sin inverse x and into n square. So again rewrite here 1 minus sin square m into sin inverse x, okay, and now m square, and that is 1 minus y square, and see y1 square 1 minus x square, and differentiate both sides with the help of Leibniz rules. So see, this is y1 square into 1 minus x square, and oh no, this is for the first point, complete first, okay. Differentiate again, this is y1 square into 1 minus x square, and this is m square and ddx of 1 minus y square, okay. And for that y1 is unchanged here, so this is minus twice x, okay. And again differentiate 1 minus x square is unchanged, and derivative of y1 square is y1 to the 2 minus 1, differentiate y1 as y2, and see m square, and this is 0, twice y1. See, the m1 square are taken common on the left hand side and right hand side are cancelled. So right now 1 minus x square and into y2 here, and this also x into y1, okay, see, and this here minus y square y, okay. This is the first question just proved here, and for the second we apply the Leibniz rules, okay. So you got the relation 1 minus x square y2 xy plus m square y equal to 0. And now for the second part of the 7 questions, and apply the rules. Use Leibniz rules. Leibniz theorem. Can you apply that? Okay. And any order derivative of 1 minus x square into y2. So this is here y1. Okay. Now this is also any order x into y1, and see m square, and this is yn equal to 0. And see for the nth order, they will start from here nth derivative of u into v. So un is the nth order, but see 1 minus x square not possible here nth order. So in the second order complete. So you apply the nth order for this, okay, y2, and 1 minus x square is unchanged here. So write nc1. Again this is here nth order, so n plus 2 here. So after that the here is the order of n plus 2. So one order decrease and differentiate 1 minus x square like minus twice there, okay. Next nc2, and the order of yn plus 1 are 1 less again, and see differentiate minus 3x is 2 here, so are not possible. Again the derivative of this part y 1 minus x square into y2, okay. For the next part we apply the again Leibniz rules. For this x into y n plus 1, so see x is unchanged and then the derivative is y n plus 1, okay. And for the second part, second step, that is nc1, and differentiate of x is 1 and the order is 1 less, so that is yn. And for the third part, and this is a notation of yn, okay. And expand the formula, and that is nc2 nc1, okay. This is nc1 here, so you can write 2xn here. nc1 means n and y n plus 1, and for that is 2 here, n into n minus 1 by 2, and this is yn. Again y into n plus 1 minus this is n1 is n and yn, okay, and plus m square yn equal to 0. And this is here is the first part, and take common y suffix n minus 1. On the next part we have taken common here yn plus 1, and this is minus here, so you also take common x here, okay, this is into x here, so left have 2n plus 1, and next part is yn are taken common there, okay. Now 2 are to be cancelled, so take a sign minus, so minus n square plus n here, so again we have right here minus n and also n square, so n are cancelled and this is equal to 0. So the result is here 1 minus x square yn plus 2 and minus 2n plus 1 into x yn plus 1, and this is m square minus n square and yn equal to 0, and this is the most interesting question for that.